Alright, for number 3. With number 3, I wouldn't necessarily expect you to be able to graph this parabola the way it's written right now. So let's go ahead and graph these two on our calculator, and then I'm going to show you some other trick with our calculator for this one. So y equals x cubed, and y equals 2x minus x squared. I'm going to change my window here. So we have the cubic function, that's first, and then our parabola. Now with this problem, I should have been a little bit more specific, because there are two regions that end up being formed by these two graphs. Well, you can't see it completely here because it ends, but if this graph kept going, this one kept going, this would be closed off. So I should have specified, and on the AP test they'll be better about that, but we want to find the area of the region in the first quadrant in this case. All right. When there's more than one region, usually it'll specify which one. I just forgot to do that. It could, not often, but it could. So let's look at this one. Our cubic function I'm going to have as the red graph, and our parabola we're going to have as the blue graph. So in that little region, that little shaded region, which is our top function? Parabola. Yeah, the top function is the top one. That's good call. Good call. All right, so this one is the bottom. So that makes setting up our integral easy. Top function is 2x minus x squared minus the bottom is x cubed. But then we have to figure out a and b. Well, again, we can just set these two equal to each other. Right, we want to find where they intersect. So we want to know when is x cubed equal to 2x minus x squared. So in this case, we want to get everything on one side. So I'm going to move it all to the left. So x cubed plus x squared minus 2x equals 0. We can factor an x out. And then we can factor this trinomial into two binomials. We get x plus 2 times x minus 1. So we end up getting three answers when we solve this equation. We get x equals 0, x equals negative 2, x equals 1. But like I said, remember, this intersects down here somewhere. Well, that's going to be at negative 2. We don't worry about that for what we're looking at here. The ones that we're dealing with are 0 and 1. Right? Intersects at 0 and 1. So we're finding the area between 0 and 1. Now, we could go ahead and do this on our calculator the way it is, and it's easy, not a problem. But I'm going to show you like a little trick for problems in the near future where it's more complicated functions, where we might have square roots, exponents, like lots of parentheses, different things going on. There's a different way we can set this up. If we graph these in our calculator, remember this is our y sub 1, this is y sub 2. So let's go back to our calculator. I'm going to go ahead and do math 9 to set up my definite integral, but I'm not going to type this in. What I'm going to do is I'm going to do y2 minus y1. So like if we have like complicated graphs that we're graphing, and we put them in for y1, y2, instead of having to type those equations in again, we can just use what's there. So to do that, we're going to go to vars, variables, y vars, and function. So I want y2 first. Remember, it's going to be, in this case, y2 minus y1. It depends on which one's top. Right? It could be y1 minus y2, it could be y2 minus y1. But in this case, it's y2 minus y1. So vars, try that again. Vars, y vars, function, y1. So that right there, y2 minus y1, that is the same as this because our y2 is 2x minus x squared. That's already typed into our calculator. Our y1 is x cubed. Like I said, in this case, not really necessary. More complicated problems, it helps out. And then we're going from x, or we're doing this in terms of x, and then going from 0 to 1. Why did... What is going on here?
Because it's a different intersection. It's like the intersection that's in the third quadrant.
There we go. So we should get 0.416 repeating. We can change that to an exact answer. And we get 5/12. Now, one other thing to point out for this problem, like let's say we're using our calculator for the whole thing, we can find these intersection points using our calculator also. So if we go back to this graph, remember to find the intersection points, you do second, trace, and option number 5 is intersect. So if I want to find this one, it says first curve, it's on my y sub 1, so I'm going to hit enter. Second curve goes to my y sub 2, I'm going to hit enter and guess, enter one more time. And it tells me intersection points at 0, 0. So we know A is 0. Then to find the other one, do the same thing, second trace, intersect. And you need to move your cursor a little bit closer to this. So my first curve, y sub 1, enter. Second curve, y sub 2, enter. Enter one more time. And then it gives our intersection point. So there will be some down the road where we have to do it this way, or like it's easier. We'll be allowed to do it this way, and we'll have decimals as answers. But remember, we can also do this to kind of check our answer if we have to show our work.